So we are toward the end, but not quite at the end of 4.2. We're doing some problems with ratios. We had a couple we did with scaling factor on the map. And then now we got a couple problems that are just a little bit different than what we've done so far. Got a couple to deal with that have multiple part ratios. Let's look at this one. This one says raw mixed nuts make a healthy and delicious snack. An online store promises raw cashews, raw almonds, and raw Brazil nuts in a mixed bag of nuts. They go even further to say that the ratio of cashews, almonds, and Brazil nuts is 2 to 3 to 5 in every bag. Assume that there are 5 ounces of cashews in a bag. How many ounces of almonds and how many ounces of Brazil nuts will the bag have? So this one looks a little different. We have to make sure we're reading it and figuring out which numbers in our ratio go with which type of nut in this case. So it says the ratio of cashews, almonds, and Brazil nuts is 2 to 3 to 5. So that's the order they're going to be in. That's the order they're going to be in. So we've got 2 cashews to every 3 almonds to every 5 Brazil nuts. And then the other piece of information they give us, they say, suppose there's 5 ounces of cashews in a bag. So it tells us we've got 5 ounces of the first one. And then we really have 2 questions to answer. We want to answer how many ounces of almonds we have, how many ounces of Brazil nuts we have. The kind of nice thing about these is we can pick and choose what parts of the ratio we use. We don't have to use it all at once. We can pick out any pair we want to as long as we're careful about what number goes with which type of nuts on this problem. So since it gives us 5 ounces of cashews, what I'm going to do is I'm going to ignore the last part right now. And I'm just going to look at that ratio of 2 to 3 of cashews to almonds. And we'll use that to set up a little equation. So I know my ratio of cashews is 2, and I have 5 ounces of cashews. These are cashews. And then that has to be equal to, I'm looking at almonds now. You could do the other one first if you wanted to. I'm looking at almonds now, so I know my ratio there is 3, and I don't know how many ounces that would be. That's what I'm trying to figure out. So got a ratio of 3 to some number of ounces. We'll call it X ounces. And then when we have these proportional equations is what we call them, right, where we have the fractions equal to each other. How do we solve those? You remember? Yeah, cross multiply. Okay. So here if I do 2 times x, that'll give me 2x. And then 3 times 5 gives me 15. And divide both sides by 2. And if first to say 15 over 2 is weird when we're talking about, normal day-to-day things, so we can divide that. 15 divided by 2, that's 7.5 as a decimal. Get 7.5 ounces, and then which one was that? That was almonds. Or first part of that one. I just set it up using the part of my ratio for cashews and then the ratio for almonds. I knew how many ounces of cashews and I wanted to know how many ounces of almonds. Set up the little equation. Are there other ways you could set it up? Yes, absolutely. We've got a bunch of different ways we could set this one up. But that's the way I set that one up. Okay. Now we got one more to do. Now we got to do the Brazil nut, and we have even more options. Okay, because we filled in some information. We know we've got 7.5 ounces of almonds. So if you wanted to, you could do almonds and Brazil nuts, okay? Or you could leave the almonds out and do cashews and Brazil nuts. It doesn't matter. Either one's going to work. To me, I think I would rather work with the number 5 than the number 7.5, so I don't get that decimal in there. I think I'm going to set it up the same way we did the last one. So I'm going to have 2, my ratio number for cashews, over 5. Then I'm going to skip over the middle part. I'll have 5 as my ratio number for Brazil nuts, and then X again. If you wanted to use the number for almonds, you can. I'm going to do it this way. I'm going to say, what was our number? 2 to 5 ounces for cashews. And then our ratio number for Brazil nuts is 5. And we don't know how many ounces that's going to be yet. Okay. And then do it just like the last one. Here, 2x equals 25. What does that? Divide both sides by 2. This time we'll get 12.5 ounces. That's Brazil nuts. Not too bad. You just got to make sure you're real clear on which numbers you're working with, that you're matching up the ratio to the amounts once you get the amounts. Questions on that one? I know that's not life-changing or anything. Nothing. Okay. Let's look at this last one. That's a little more interesting. Slightly. Let me get through all these textbook slides. Oh, went too far, sorry. There we go. So a little, slightly more interesting. Okay. So this one says we're in a hardware store. We got a bag of miscellaneous nails. Tells us the total number of nails. We've got 300 total nails in the bag, and it says it has a 4 to 5 to 6 ratio of nails in decreasing length. So that's long, medium, and short. We want to know how many of each nail should the bag have. So we've got a total of 300, and then we're writing down our ratio. We got to make sure we're clear on which number goes with which type of nail. It says they're in decreasing lengths, so 4 would be the long nails, 5 would be the medium, and 6 would be the short. And we want to figure out how many of each nail we have. This one's a little bit trickier, because it doesn't tell us how many we have of any of them. We have to figure all of them out. So might seem that we don't have enough information, but we do. Because it gives us the total number of nails. So we got a little trick here. In our ratio we're given, we don't have a total, right? We've got the ratio of each type of nail to the other types of nails. But we can get a total. What can we do? We can add these up. So 4 plus 5 plus 6. If we do that, we get a number we can use in our ratio for the total. That's 15. How's that going to help us? Well, now we've got to ratio of something to 15 total nails, and we know how many total nails we have. So we just pick out which type of nail we want to find first. Okay? We can do any of them. Maybe we'll do small nails first. It doesn't matter. Okay? So I'm going to set up a little equation because I know that I've got, well, let's do the total on one side. So I know I've got 300 total nails. And my ratio number for that is 15. So this is like the total side. And then I'm going to do the information from my short side over here. So over here, I don't know how many short nails I have, but I know my ratio number was 6. And then same song and dance, right? We got proportional equations, so we cross multiply. Okay, so 15 times x, 15x. 300 times 6, 1,800. And then we divide both sides by 15. I don't know what that is. That's 120. And then just make sure you're keeping track of what we're finding. Those are the short nails. Okay. So once we did our little trick, it's not any harder than the last one. A little more interesting because we get to add those ratio numbers up. Now, we've got 2 more to find. We need mediums and long. Okay. And we've got a bunch of options because we just figured out that we've got 120 short nails. So if we want to, we don't have to use the total anymore, or we can use the total, it doesn't matter. We could do like 6 to 120 is 5 to x and find the medium if we wanted to. Or we could do still 15 to 300 is 5 to x. Right? Use any parts you want. Whatever jumps out to you first. Okay. So I guess I'll use our new number. Okay, does it matter? So I'm looking for medium nails. Let's do a new slide. Looking for medium nails. I know I have a ratio of 6 short nails and a count of 120 short nails. For medium nails, I have a ratio of 5. And I don't know how many of them I have. That's what I'm trying to find. And so the top numbers are out of the ratio, and then the bottom numbers are the actual counts of nails. And we, same trick, cross multiply. That one's a little easier. Divide both sides by 6. Get 100, and these are 100 mediums. There's that part. So filling out what I know I've got 100 of these. Then how can we get large nails? Got several ways, but you could do that. You could use the 6 and the 120, and then 4 and x. Or we got a simpler way. We don't even have to do ratios now. Yeah, we know we got a total of 300. We know we got 100 mediums, 120 shorts. So yeah, if you don't like ratios, you can be finished with those now. Okay, so got a total of 300 minus the 120 mediums minus the 100 shorts. we get there, so we get 80 long nails. Finished it. Questions on any part of that one? You're real quiet today. Can't think of anything? Think of a question not about math? Nothing, just nobody wants to talk. Okay. Bring some candy in or something. Give it away like middle school. All right, that's the end of 4.2. That's all of it. Once you get where you can do the multi-part ratios, you're in good shape. 4.3 is pretty short. 4.3, we are thinking about percentages as the main idea. We've written some ratios for what we call a proportion, and then we're going to rewrite those as percentages. And so percentages are nice. They're easy to think about. It gives us kind of a common way to, common ratio type deal. We'll see that in a second. Okay. So let's talk about what a proportion is first. We've already seen them and worked with them. We just didn't define it. When we're talking about a proportion, we're talking about a fraction of a whole. So like if we figured out how many students in here were freshmen out of how many total students we had in here, that would be a proportion. And so we would write that as a fraction. Get a proportion. Okay. That's all there is to it. So the nice thing about taking a proportion and thinking about it as a percentage, now what does percent mean? You might not have even never thought about it before. Percent. We've seen already per, like when we're dealing with rates, per means you're going to divide. Okay. And then cent, how many cents are in a dollar? 100. Or how many years are in a century? 100. So cent we use for 100. So all a percent means is we're dividing by 100, or we're writing our proportion with a denominator of 100. Okay. And the reason we do that, we're just picking, okay, we could pick whatever we wanted to. 100 is a nice number though. So we're picking 100 to be our common denominator that we're making comparisons with. And what we do is we make the denominator 100, and then that lets us think about and compare the tops, the numerators, because they have the same denominator. So with percentages, all we're doing is we're making the denominator 100 and then comparing the numerators. Even though we don't normally write a percentage like a fraction, okay? We normally write it with a percent sign. That's what we're doing. We're changing it to be over 100. Okay? So if we just have any fraction, okay, with some other denominator, and we want to change it to a percent, you could, okay, right? Our goal is to make the denominator 100. You could try to figure out what number you need to multiply top and bottom by so you get 100 on the bottom. But usually that's a little more work than this way. Okay? The most common way we change a fraction to a percentage is we take the numerator, divide it by the denominator to get a decimal. Okay, so here we would do 3 divided by 8. So that's going to give us the decimal form. This one comes out to 0.375. Okay. But then to change it to a percentage, dividing by 100, okay, or really multiplying by 100 here, all that boils down to is we're moving the decimal place twice. moving the decimal 2 places. So here to change our decimal to a percentage, all we're doing is we're moving the decimal place. We get 37.5, so 37.5%. Have you seen that trick before? Okay. Well, that's our little process. We're going to do it on some of these problems here. Okay. We don't have too many. It's a pretty short section. Let's look at this one. So we got a table. It gives us some information regarding car sales in 2014. Remember, our textbook's getting kind of old. Okay. So we got some different categories of cars, and then how many cars were sold in that month. Okay. And then we're going to have a question here. A question, for example here, tells us to find the proportion of mid-sized cars that were sold. Okay. And when we do a proportion, we're always comparing it to the total. So where these numbers are coming from here, we're taking the number of mid-sized cars and dividing that by the total number of cars sold. Okay. So 311,000 something divided by 676,000 and something. Okay. And on this one, all the good it does. There is a common factor of 2, right? You can divide top and bottom by 2 and get it into a smaller proportion, but that's as simple as that thing goes. Okay, which is a hard number to think about, right? Like if you're just trying to think about what this number means, okay, 155,000 out of 338,000 and change. Okay, that's hard to wrap your head around. Those are pretty big numbers. So what we can do instead, okay, makes it a little easier for us to think about and compare to other numbers, is for us to change it to a percentage. So what do we do to get our percentage? We take and divide it out. Okay. So 155,664 divided by 338,137. Okay. Oh, I guess we need to do that. Okay. So we're doing this so we can get the decimal version. Okay, so let's see how that comes out. Okay. So as a decimal, I got 0.460357, and it goes on and on and on. Okay. So to make it a percentage, and we're going to multiply by 100, or you don't even have to remember that. Just remember we're moving the decimal place 2 places. Bless you. So on this one, it doesn't tell us a particular number of places to round to here. We're just estimating, so that's about 46%. A little over. About 46% of cars sold that month were mid-sized cars. Any questions on that one? Okay. Let's do another one. If you remember how to do this, then it's super boring. If you don't remember, you're glad we're doing a couple of them. Okay, so it says change the fraction 75 out of 234 to a percentage. Okay, so do top divided by bottom to get the decimal. Okay, so here I get 0.32051, and it goes on and on and on. And then either think about multiplying by 100 or move the decimal place 2 places. This one, it doesn't tell us how to round here, so I'm gonna call that about 32%. Maybe you say 32.1% if you wanted to round to one place. Or percentage. All right. Look at another problem here. All right, this one said the following sample of adults between the ages of 25 and 34 reported whether they had a college degree or not. What proportion of these adults reported having a college degree? And then we want to change our proportion to a percentage. So to get the proportion, we're counting the ones that had a college degree. Okay, so we want that number, 373, out of the total 1,002. Okay, so there's our proportion, 373 out of 1,002. And then we will divide that, 373 divided by 1,002. Get the decimal. And then we're going to move our decimal place twice to get, I don't know, 37.2%. It doesn't tell us how to round here. Just have to pay attention on Hawk's problems. It'll say round to the nearest tenth would be what we did here. Or if it says hundredth, that's 2 decimal places. Or if it just says nearest percent, then you don't have to have any decimal places. A little over 37% there. And if you look back at the proportion on that one's not too hard. You can kind of cheat and estimate. What can you do? What am I talking about? You can kind of, since the bottom's really close to 1,000, you can kind of think about canceling out those last digits there. That's really close to 37 out of 100, which would be 37%. So you kind of estimate that. Sometimes you can, sometimes you can't. If you have an ugly denominator, then it's really harder to see what you're going to be close to. All right, maybe this one will be a little bit more interesting here. Our class is not quite this big. Okay, but we can get there. It says the proportion of people who are left-handed is approximately 1 out of 11. And it says if there are 45 people in a room, estimate how many of them are left-handed. Okay. So what can we do on this one? We know our proportion is 1 out of 11. How do we figure it out? So quiet today. It's okay to be wrong. Just yell something out. We're gonna multiply. And if you want to change it to a decimal first, you can. Okay. But we can do it with a calculator too, anyway. So here, what I'm going to put in is I'm going to put in 1 divided by 11 to get my fraction, then times 45. It goes on and on and on. That's really repeating, so you've probably seen this before, but if you see a bar over the top of some digits, that means those digits repeat themselves over and over and over. And that happens here because if you do 1 divided by 11, just do it as a fraction, as a decimal. 11's a kind of a weird denominator. You just get 0.090909090909. So if we had 45 people in a room, we could expect to have about 4 that were left-handed. When everybody's here, we've got about 30 people. It's probably a little less than that. Let's say 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We got 23 people here today. So let's see how many we should expect. Same thing. 1 divided by 11 times 23. That would be 2.09 repeating. So we should expect to have 2 left-handed people. How many of you are left-handed? Oh, we got 3. And so we're a little over expected. Okay. So that seems pretty close. Okay. Let's see. One more here for us to work, and then I got one just for us to look at because it's kind of neat. Okay. How we're doing. Good. All right. I don't even remember this problem. It's supposed to be in the last section. Maybe I had to cut it out, but it said there was a new freshman class with a ratio of 2 to 3 men to women. Maybe we did do that one. And it says university-wide, 53% of the campus population is men. Is the proportion of men in the freshman class different from that of men campus-wide? So how can we figure that out? Well, a couple ways we could think about it here. We had the ratio of men to women given to us. So we could change that to a percentage. Okay? Ratios, they're fractions. 2 to 3 men to women. So we could change that to a percentage. That one's going to be 0.6 repeating if you divide that out. So as a percentage, it's going to be like 66.7% men, women. But wait a minute though. I think I led us astray. Because what's the issue there? We had one thing we need to do first. Our ratio here is men to women. So that's not going to give us a direct comparison here because this is saying 53% of all the students. So we're not comparing men to women, we're comparing men to everybody, comparing men to the total. So what do we got to change over here? We don't want 2 to 3. We got to use our little trick we did with the nails. To get the total, we need a number for our total, so we could add these two together. 2 plus 3. So that would mean 2 out of every 5 people was a man there. So that's 0.4. And when we're changing to a percentage, you can always add zeros. That's 40%. So 40% of the freshman class is male. University-wide, 53% of the population is male. So yeah, they're different. Smaller percentage of males in the freshman class. Does it make sense how I messed up to start with? How we can't just use 2 to 3 because here we're looking at men to women, and we want to look at men to the total. So we got to add these two together. Because 53% saying 53 men out of 100 people. What that's saying. Okay, one more. You don't have to calculate this one. This is just kind of mind-blowing. So look at this one. We'll be done. All right, so a little science review. All right, the Earth's got 3 layers: crust, mantle, and the core. And it gives us the percentages. Core is 31.5% of the mass. The mantle is 68.1% of the mass. But then it tells us even though the crust is 20 to 30 miles thick, it only makes up about 0.4% of the mass. And it gives us an estimate for the total mass of the Earth and asks what's the mass of the Earth's crust. So the way the math works out on this one, if this is the percentage of the mass that the crust is, all we would have to do is take this number times this number. It's a little ugly because we've got that scientific notation. But what we would do is we would change this to a decimal first. So we would move our decimal place 2 places to the left. That's a 0.004 times that really big number. And that, I'm not going to make you calculate it, but here's the calculation. And put that back in scientific notation. That's what we get. But that doesn't do it justice. Okay? Because of the scientific notation, it doesn't make it look that impressive unless you're just real familiar with scientific notation. Here it is with all the zeros. So about what's the mass of the Earth's crust? A lot. Okay? What's our number? So here we got hundreds, thousands, millions, after millions. Billions, yeah, in the United States, billions. Okay? And then what's after billions? Trillions, yeah, this is the area where the United States debt is, in case you're curious. Then it's a little weirder, you don't hear it as much. Quadrillions. You got a guess after quadrillions? Quintillion. Okay. And guess? Sextillion. Okay, 6. And so it's about 23 sextillion, 896 quintillion, 800 quadrillion kilograms. A lot. It's just a mind-blowing number. So, questions on that one? You're not going to have to do it with scientific notation or anything. It's just one for us to look at. Okay. All right. So let me give you your test back. That's the other thing on the docket today. So I will give you these back. Look over them. We will talk about any of it we need to talk about.